here we're going to talk about 3 problems from University Physics Chapter 9, Rotational Motion. Let's get started. 9.23, a flywheel with a radius of 0.3 meters starts from rest and accelerates with a constant acceleration, angular acceleration of 0.6 rads per second squared. Compute the magnitude of the tangential acceleration, the radial acceleration, and the resultant acceleration of a point on its rim, A at the start, B after it has turned through 60 degrees, and C after it has turned 120 degrees. This is the given. Again, alpha equals 0.6 rad per second squared, radius is 0.3 meters. Now first we have to find at theta equals 0, or at the start, as said in the problem. Tangential accelerations r times alpha, substitute the given, and we'll get 0.0180 meters per second squared. Next we'll get radial acceleration, which is omega squared times r. To get omega, we'll need to use this equation, and since it starts from rest, omega sub I is 0, we can square it both sides and get omega simply, and we can substitute that to the equation for radial acceleration. We can simplify this further since it's a square of a square root, and that will be simply 2 alpha theta r. Substitute the values, and we'll simply get radial acceleration equals 0. Now for the resultant, substitute to that equation square root of the square of tangential and radial acceleration. That's square root of 0.0180 squared plus 0 squared, and you'll get the answer, which is simply equal to tangential acceleration. Now at theta equals 60 or pi over 3, we'll simply repeat the process. So tangential acceleration, substitute the values again, you'll get the same answer. With radial acceleration, again, you'll get 0.377, and resultant, substitute again, and you'll get 0.377 meters per second squared. Now at theta equals 120 degrees, again substitute, it's the same as A and B. And for radial acceleration, get 0.754, resultant, get the substitute again, and you got the answer. Now 9.75, an advertisement claims that a centrifuge takes up only 0.127 meters of bench space but can produce a radial acceleration of 3000 g at 5000 revs per minute. Calculate the required radius of the centrifuge. Is the claim realistic? Now, sorry about that. Now 0.127 meters bench space means a radius at most of 0.0635 meters. Now we need to find the realistic radius for the advertised radial acceleration and angular velocity. So first we need to convert omega into rads per second. So simply multiply that to 2 pi and divide it by 60 seconds. We'll get 500 pi over 3 rads per second. And after that, we can now find r. Starting with the equation for radial acceleration equals omega squared r, transpose, and we can get radius equals radial acceleration over angular velocity. And then we can substitute the values, and we can get a radius of 0.107 meters. It's greater than the radius that's in the claim, and therefore the claim is not realistic. Finally, we have 9.63. A circular saw blade with radius 0.12 meters starts from rest and turns in a vertical plane with a constant angular acceleration of 3 revs per second squared. After the blade has turned through 155 rev, a small piece of the blade breaks loose from the top of the blade. After the piece breaks loose, it travels a vertical distance of 0.82 meters to the floor How far does the piece travel horizontally from where it broke off the blade until it strikes the floor? Now, since it broke off from the top of the blade, we'll assume that the piece travels horizontally, tangentially to the blade. Yeah, I forgot to place it in the problem. It was mentioned in the book that it traveled horizontally. So here's the given. We know that since it travels horizontally, it will travel in a half parabolic trajectory once gravity acts on it. So first we'll need to solve the tangential velocity, which will be in turn the initial velocity. So that's the trajectory, that's the the blade. And first we need to find the tangential velocity, or the initial velocity once it becomes parabolic motion. And tangential velocity is simply r times omega. Omega is square root of 2 alpha theta as solved in the previous problems. Substitute that to the velocity equation, and so you can substitute the values to get 22.99 meters per second. Now we can find x using the tangential velocity as the v sub x. And now for this equation, we need to find time. So we can use the height it traveled. And since VIY is equal to 0, since there's no vertical component, we can just scratch that out. And we can transpose to get time equals square root of 2y over g. Now we can substitute that to the original equation, x equals vxt, to get this equation. And we can just substitute the values, substituting vx with v. This v we solved earlier to get x equals 9.41 meters. That's the end of the problems. Thank you for listening.